All right, hello everyone, welcome. I hope you all had a great weekend. Of course, we are here today to talk about the exam that is coming up. So I'm going to spend the first few minutes of class just kind of going over the exam logistics, talk a little bit about the exam, and then we'll open it up to you all to hopefully ask some questions for me to work through for you today to help get you ready for the exam that's coming up on Thursday. So first off, just want to remind you all that this is an evening exam. It's taking place Thursday evening from 6:30 to 8:30. It's taking place in multiple rooms. However, the room that you went to for exam 1 should be the same room that you need to go to for exam 2. The rooms have not changed. So you should be able to go to exactly the same room that you went to take the first exam in order to take exam 2. The information is here on the exam page if you need to remind yourself about where to go. Also, just like on the previous exam, you are allowed to bring a sheet of paper with you with notes on it. So it's just got to be a regular size sheet of notebook paper or printer paper. If you bring a poster, then I'm going to tell you to get rid of it. If you can put handwriting on the paper. You can type out your notes for the paper. Just remember that I should be able to look at it and read what's on your paper without needing any extra fancy tools or 3D glasses or whatever the case may be. As far as the contents of the exam itself, it's going to cover modules 4, 5, and 6. So I feel like I've said this 1,000 times, but I'm going to say it again. The material that we just covered on Module 7 is not going to be on this exam. So you will not see constructors. You will not see instance variables. You will not see any of that stuff on this exam. We will continue that conversation about objects next week after this exam is finished. But everything that you see on this exam will be we'll use static methods. And in fact, knowing the difference between static methods and non-static methods, not on this exam. That'll be on the next exam. That'll be on exam 3. For what that means for you is that actually, I think most, if not all, of the exam questions will already be written out as static for you, so you won't ever have to guess or make that determination for yourself. As far as the material itself, Module 4, that's when we covered APIs. We talked about a couple of different APIs. We talked about Scanner, which we've used quite a bit. But the big one that we used in Module 4 was Standard Draw. So that's when we first talked to you about how to draw stuff on the screen, how to do animations, which you had to do for assignment 5 and 6 a little bit, or I'm sorry, and 4 a little bit. I do want to point out that you do not have to memorize what's in Standard Draw. That is not a good use of your time. You should not put all of Standard Draw on your cheat sheet. That is also not a good use of your cheat sheet, of your sheet of paper. If you need something from Standard Draw or any other API that I choose to put on the exam, I will tell you about it. So if you need to draw circles on the exam, I will tell you that there is a method called circle that takes in an x coordinate and a y coordinate and a radius. I will give that to you. That will all be given to you on the exam. You do not have to memorize that. You do not have to write that down. You do not need to put that in your notes. So please keep that in mind as you're studying, as you're preparing. That's actually kind of the point of Module 4, is if I tell you about a method, I say, here's a method, here's what it takes, here's how to use it, you should be able to use it, right? Just based on that information alone. That's kind of the point of Module 4. So don't feel like you need to memorize all that stuff. If you need it, it will be given to you on the exam. Module 5 was about methods. So, writing methods, using methods is actually a big part of what this exam is about. And then, of course, Module 6 is about recursion, which is probably what's on most people's minds when they take this exam. However, I just want to be absolutely clear that while recursion is something we covered, recursion will be on this exam. Don't overdo it. Don't overcomplicate things. A lot of times, if I want you to use recursion, I will say, specifically on a problem, you have to use recursion to solve this, right? If I don't say that on a problem, then you can do whatever you want. I see a lot of students, they get so focused in on recursion that they try to use it on every single problem on the exam. You're not going to have to do that. I mean, you can. I'm not going to tell you that you can't use recursion if that's what you really want to do. But remember, there's still a lot of stuff that is perfectly fine to do with loops. So a lot of cases, if I don't tell you you have to use recursion, and you're like, I'd rather do this with a loop, use a loop. Please, please. Do not force recursion into problems that don't specifically require it. Most of the time, that's just going to make it harder and more complicated for you. So just something to keep in mind. Read the problem descriptions very, very, very carefully. If I want you specifically to use recursion on a problem, I will tell you. I will tell you that information. Otherwise, it's up to you. Pick the easiest one. Don't make it any harder on yourself than you have to. I think that's just about all I have to say in terms of the exam itself. Does anybody have any questions about the logistics, the where, the when, what you can bring as far as notes? Any questions about any of that stuff at all before we switch over and hopefully do some coding problems for the rest of the time? Okay, so then I want to also point out, as I hope you're already aware, that just like the prior exam, I have posted some materials that you can use to help you study. So I have this practice quiz of past exam 2 questions. These are going to be fill in the blank, multiple choice, true and false style of questions on this practice quiz. And then there's also a repository that is filled with coding problems, both code reading and code writing style of problems. I actually have that already loaded up into Eclipse, and I'm hoping that you all will have some of these problems that you would like to see me walk through in class today. And that's what I'm going to do next. I'm going to open up the floor. If anybody has a problem they'd like to see me walk through, I'm happy to do it. If nobody gives me one, then I'm probably just going to start picking some of these at random and doing them. Yeah, go ahead.
Could you go over question 1 of the writing?
Absolutely, I'd be happy to.
I was just confused, I got the shapes down, but those squares are overlapping.
The squares were overlapping in the pattern? Okay, well let's talk about this problem and work through it and see how far we can get on it. So this is a drawing problem. But it also involves recursion. You can see there's that R word right there. So this is a recursive drawing problem. We gave you an image 01, so this one right here. Anytime you're faced with, any recursive problem, but specifically the drawing ones, it's very important to understand where the patterns are. So where's the pattern repeating in this recursive drawing problem? I can see that there's a square in the center, and then there's 4 more squares. One going top left, top right, bottom left, bottom right. And then from each of those, it looks like it keeps going, right? Top left, top right, bottom left, bottom right. So I see this pattern repeating 4 times. This recursive pattern is repeating 4 times. What is this problem an example of? There are styles of recursive problems like this. We call them, this is an example of what kind of recursive problem? Max path length is one. Circles upon circles is one. Divide and conquer. Yeah, these are divide and conquer problems where I see the pattern repeating multiple times. That means I'm going to have 1 recursive call for each of these repetitions. So 1 recursive call for top left, 1 for top right, so on and so forth. So let's go ahead and start trying to figure this out. The first thing actually that I like to think about when I'm dealing with recursive problems is when we're going to stop. What's it called? The part where we stop in a recursive problem is called what? Base case. Good. Yeah. So we got to figure out what our base case is. The good news is for these kinds of recursive drawing problems, the base case is going to be pretty similar. It's always going to be based on. Oops, that's not this problem. That's a different one. It's going to be based on the size. So you can see I start big, and then I work down to smaller and smaller squares, and eventually the squares are going to get so small that I'm not even going to be able to see them anymore. That's when I stop. So the base case for these kinds of recursive drawing problems is almost always going to be based on the size of the thing that is being drawn. And if I want to say that in code, we have to take a look first at what information I have available. I've got this center point x and y, and a half length. So this is really my size, right? The half length. So, all right, if the half length is greater than, well, I mean, you could say this in two different ways. If it's greater than, some size, that means keep going. Or I can say the opposite. I can say, if the half length is less than some arbitrary size, I need to stop. How do I say stop? Return. Good. Return. Remember, return has two purposes. One of them is what we're using it for right here, which is to say stop. We're done. The other thing that return does for us, we're not using here because we have a void return type. But if we had a non-void return type, we could use the return statement to state what the output is, what the return value is. Okay, so if we're below a certain size, we're going to stop. Otherwise, we need to keep going. And what does it mean to keep going? Well, we need to draw the square. That's probably the first step. So I'm going to draw the square with this given size. And then we need to perform our recursion. So there's going to be 4 recursive calls here. And we have to figure out, if I am starting at this big square in the middle, how do I get to this next position up here? So starting from this center point, I'm going to move over 1 half width, 2 half widths in the x direction. So that's going to be subtraction, right? I'm going to move up 2 half widths in the y direction. So that'll be addition, right? So if I piece together a recursive call with that information, I'm going to subtract 2 times the half length from my x direction. That's going to move me over to the left. I'm going to add 2 times the half length to the y direction. That's going to move me upwards. And then we have to decide how the size is changing. So the size of this to the size of this, it looks like the half width is going down, I would say, roughly in half. So I will divide the half length by 2. I need a semicolon on the end here. We're not finished yet. Remember, I said we need 4 recursive calls. I've only done 1. But at least at this point, I can, try it out and see, is it actually going to work? And okay, looks like I've got a couple of issues here, right? One is that these need to be filled squares. So that's an easy fix. Filled square instead of regular squares. The rest of it seems to be working okay, although it's going off the edge of the screen. I mean, that's not necessarily a problem. That doesn't necessarily mean that I'm drawing this improperly. Let's go ahead and add in the other 3 recursive calls and figure out how we need to fix those. So the first one was for the top left. I was moving left, so I subtracted the x direction and added the y direction. If I'm going to top right, I'm going to add the x direction and add the y direction, right? So if I take a look at this recursive call, all I have to do is switch that to a plus, and now I'm doing the top right. For the bottom left, I'm subtracting from x and subtracting from y. So I'll flip this to a minus sign on the 3rd recursive call to take care of the bottom left. And then finally, for the bottom right, I am adding to my x direction, moving to the right, but subtracting from the y direction. So I need to flip both of these signs here. Oops. Like so. And I believe we're going to have something that hopefully... Oh, okay. So it looks like we're in kind of the right ballpark-ish. It looks like maybe my base case is a little bit off, perhaps. Maybe I need to... Do I need to stop sooner? Oh, now it's taking even longer. I need to stop sooner. I need to take some zeros off, maybe, from here. Oh. Well, another issue that I think I have with this problem actually is not to do with this part. I actually think it starts too big. I actually think the initial starting size is actually a little too big. I think if we actually change this, make it a little smaller, we'll see that it fits the image a lot more clearly. Let me change my base case back to how it was before. Oh, wow. I'm getting there. You can see it's very close to the image, although you mentioned overlap, right? You can see it's kind of overlapping here too. Is the size going down by 3 instead of 2? I mean, that's another question you could ask. That looks a little bit better, to be honest with you. However, let me point out that all of this number tweaking that I'm doing right now, oh, okay. There we go. So I was decreasing the size of the squares by half, but once I decreased it by 1/3, it started to fit on the screen a lot better, right? You notice that it fit on the screen a lot better. I want to talk about that though, because on the exam, right, you won't be able to do what I've been doing here. That's very fair to point out. I can't tweak the numbers until they look exactly right on the exam. I understand that. I very, very, very much understand that. So I want you to understand that on these problems, especially when there's a visual element to them, there's a visual component to them, if these numbers are a little off, you will not be marked wrong for that. I want to make that absolutely clear, right? Same thing for this base case, right? How many zeros should this have? I don't know. That's not the point. That's not the point of the problem. The point of the problem is that you get the structure right. You recognize that the base case is based on the size, and it will stop once it gets to be too small. You recognize that there are 4 patterns that show up here, and you give me those 4 patterns: top left, top right, bottom left, bottom right. That's what I'm looking for on these kinds of problems. You will not be graded on how correct this number is. I would not expect you to be able to say that just from looking at this picture. That's not a reasonable thing for me to ask. So please know that there is wiggle room. Sometimes I'll actually directly state it in the problem. Stop drawing shapes once the size is below this. Sometimes I tell you directly what it is. If I don't tell you directly what those numbers should be, use your best judgment and trust that I'm not going to be that nitpicky as to take points off if you're a little off on those problems, on those numbers. Hope that helps sort of eliminate some fears on these kinds of problems. Was there a question? I thought I saw it. Yeah.
I'm just asking about like the x and y minus or plus like 2 times the half, like the vector is in 3 times or anything else, so that serving example in the number.
You're asking me if this number should be 3 instead of 2? I'm not sure I understand the question. No, I understand. Is that what you're asking me though? Like if you switch all these to 3 instead of 2? So I'm not going to be nitpicky on the numbers. That is not what I'm interested in. If you get the right structure for these problems, to me, this is still generating the same image. I just got to zoom out a little bit. Like not worried about the actual numbers. Any other questions about this problem? This is a divide and conquer problem. These are a common set of problems. You can see there's at least a few of them in this set that follow this pattern. Maybe we'll do another one later on. I don't know. We did a couple of them last session. If there's no questions on this problem, does anybody have another problem they would like to see me go through? Code reading problem, code writing problem? Yes. Question 9 for the code reading. Whoops, that's code writing. You said code reading. Okay. Oh, good. I'm glad we're doing one of these. Yes. This one is asking us to show the substitution method, or rather use the substitution method to show the evaluation of a given recursive method. Very happy to do one of these problems. Almost a guarantee that there's going to be a problem like this on your exam on Thursday. So here's how I'm going to do it. I mean, you're really pretending that you're the debugger in this case. You're showing me the execution of this program step by step by step by step, all the way down to the base case and then back up again. And so let me show you how I would approach this problem. I would actually approach all substitution method problems this way. I'm going to start off with what we're given. We're given this. So, all right, function of 4 is equal to what? Well, plug 4 in here and see where you end up. Is 4 greater than 25? It is not, so I end up down here, which means the function of 4 is going to be equal to the function of, 4 times 2 is 8, minus 1 is 7, plus 1. Everybody with me so far? So now I have to figure out what this is. What is this? All right. Function of 7 is equal to what? Well, I'm still not greater than 25. So I'm going to go back down here. 7 times 2 is 14, minus 1, that'd be 13, right? Plus 1. All right, well, what is this? What is that equal to? Function of 13 is going to be equal to, I haven't hit my base case yet. It's still not greater than 25. So 13 times 2 is 26, minus 1 is 25, actually, as a matter of fact. But be careful, because this says strictly greater than 25, and we are equal to 25, so we're actually not quite at our base case yet, right? We have to do one more trip through, so 25 times 2 is 50, minus 1 is 49, plus 1. And now, when I look at the execution for 49, I'm at the base case. And it says return k. So if I plug 49 in, that's what I get back out. I get 49. But we're not done yet. 49 is not the answer, actually. We still have more work to do. And this is where the substitution method gets its name from. Now that I know what this is equal to, I'm going to take this value and I'm going to substitute it in on the previous line. So I take my known value and I substitute it in. So if I do that, I get the function of 25 is equal to 49 plus 1, which is 50. And now that I know what this is equal to, I can take this 50 and I can substitute it in here. And I'll keep performing those substitutions all the way back up. So now that I know what the function of 13 is, I can do function at 7. That's going to be 51 plus 1, 52. And then finally, my original call is function of 4 will be 52 plus 1 is equal to 53. And so 53, in fact, is what I would expect the result of this to be. Notice that it requires us to go all the way down to the base case and then come all the way back up, performing these computations on the way. This is what I would write down for this problem. Do you have to follow this exact format that I've given you here? No, you don't, but I definitely want to see all of the method calls, right? Every single recursive call I need to see. And I need to see this value at the end. Definitely need to see what the final value is at the very end. As you can imagine, one of the more common mistakes that happens on this problem is that people will come to here and then they'll stop. And say, that's my answer. Well, it's actually not. You got more work to do. And, you know, please, 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 I know you can't do this on the exam, but you definitely can do it when you're studying for the exam. Use the breakpoint. We're quite literally, use the debugger. We're quite literally going through this just as we would with the debugger, just as a computer would execute this. I'd like to do that real quick, show you that, okay, if I start at 4, my next recursive call is going to be 7. There's my 7. And if I keep going, I hit 13. Then 25. But that's still not the base case, so I end up at 49, and that is my base case, right? What's this called over here that keeps track of all the different recursive calls that I have? What's this called? It's a stack. It's a call stack. Yeah, method call stack. That's exactly right. That's a good vocab word that could potentially pop up on the exam, for sure, for sure. Once I hit my base case, we actually have to travel all the way back up through these. So the value of 49 is going to get tossed back up. And I'm going to add 1 to it, which gets me 50. Add 1 to that, gets me 51, 52. And then finally, here I am at my original version where k is equal to 4. I add 1 more value to that, which gets me the final result of 53. Are there any questions about the substitution method or how I use that to evaluate a recursive method? Okay. No questions? Then what's next? Does anybody have another problem they would like to see me work through next? Yes? Question 8. Be happy to. All right. So we want to create a method. It's called count values. It's going to count and return the number of times a particular value appears in the columns of a 2D array. So here's a 2D array. If I wish to count the number of times that 1 appears in each column, I can see that 1 appears in the first column twice, right? It doesn't appear in the second column at all, so 0 times. And then 1 appears in the third column just once. So I want my count values method to return a one-dimensional array that contains that information. Notice it appears twice in the first column, 0 times in the second column, and once in the third column. So that's all just to explain, how this works, how this method's actually supposed to make sense. Let's come down here and start working on this. We need a one-dimensional array that's going to store these values. How big should this one-dimensional array be? The number of columns. The number of columns from my given two-dimensional array. So I'll make a result array. Oops. Need to make sure it's an array. And for the size that I have to put inside the brackets here, I'll use the columns from this array. Notice that this is what distinguishes it from this, which would be the rows. This would be the rows. That's not correct. This is the columns. That's what we need here. 1 entry per column. Okay. Now that I have that, I just need to start, figuring out where these ones appear. I need to check every single element in this 2D array, right? I need to check every single element and see if it's the one that I'm looking for. So if I'm visiting each and every single position of this 2D array, I hope your brain is going, oh, I need that nested loop structure, because you absolutely do. This is a situation where we need that nested loop structure. So for int I is 0, I is less than a dot length, I plus plus. This is going to be for our rows. Then we'll do another one for our columns. Typically use J for that. Oops, I forgot a word. J is less than the number of columns. All right. So to extract an element from the array, I would just say A at I, J. Oops. But actually, I'm not just trying to extract the element out of this array. I'm trying to see if it's equal to this parameter. So we need an if statement here. If find me is equal to whatever value is at the array at this point. I then need to update my result array. I need to add 1 to it at the proper value. So which value of my result array do I need to change? If I find a value, right, which position in my result array do I need to update? Remember, the result array contains 1 element per column. I have just located this value. I know that it is in which column? Column J. Column J. So which result do I need to update? I need to update the result in position J, because that's tracking how many times I've seen the value in column J. And actually, I think I can just say Or you can add 1 to it the long way if you want to. That's fine as well. I'm almost done. I'm just missing one more statement. Anybody know?
The return statement.
The return. And Eclipse is telling me that it's mad. It's like, hey, you told me that I was going to give you were going to give me an integer array, and you haven't done that yet. So I need to return my result down here. I believe we actually have this example for you down at the bottom. So hopefully if we run this, we should see these numbers come back out. 201. Let's try it. See what we got. There they are, 201. And you can easily test this by just switching, how many ones appear in your array, right? If I add some more ones in to my array, it should now be 3, 1, 2, because I have 3 ones in the first column, 1 1 in the second column, and 2 ones in the third column. So if I tweak my array and I run it again, 3, 1, 2. Beautiful. Properly figuring out where those values are. So this is the result. This is the answer to that particular problem. Any questions? Any questions on this one? Okay. If there aren't any questions, does anybody have another problem they would like to see me work through? Or should I start picking some problems for us to work through? Oh, yeah. We can do another one of those. Sure, yeah, absolutely. There's a few of them down here that, with the images on them. Maybe I'll do like this one. I think might be a good one to run through. Which I believe is it number 11? No. Here it is, yeah. I'm working on code writing problem number 12, which has us draw this image here. Now this one's a little bit different than the one that we did before. You can see there's more than one kind of shape. Right? I have squares, and then eventually it switches to circles. But when? At what point does it switch to circles? It looks like it's still based on the size. You can see that all of the squares that are drawn are bigger than all of the circles that are drawn. So really, we're just making that switch once we get below a certain size. That's the extra little wrinkle on this one. What are the directions that I'm moving in? How many directions am I moving in for this one? This is a divide and conquer problem. How many divisions are there? How many directions am I moving in? 2. Just 2 for this one. I'm moving up and to the left. I'm moving down and to the right. So if I look at the big square, where's the next biggest square up here? There's one up and to the left, and there's one down and to the right. And where do the next biggest squares appear from there? Up and to the left, down and to the right. So this is a divide and conquer problem where we're going to have 2 recursive calls, one going up left, one going down right. But we also have to figure out how to accommodate this shape change that occurs. So let's get started. I'm on oh gosh, I already forgot which one. Here it is, question 12. Perfect. We are given the center point and the size, where this size is either going to represent the size of the square or the size of the circle, depending on which shape I'm drawing. But this size also determines which shape I'm drawing, right? So actually, why don't we start with that? If the size is greater than 0.05, right? I'm just guessing here again, right? Like, I don't know what that actual number is. Oops, that's not the right image. I need to close some of these tabs. I got way too many tabs open. This is the problem. No, that's not the problem that we're doing. All right, let me fix this once and for all. Okay. Now I will stop opening the wrong tab. So if the size is greater than 0.5, then I'm going to draw a square. And if it's less than 0.5, I'll draw a circle. In both cases, I'll just plug in the x and y coordinate and the size directly. The only difference is the shape. For bigger sizes, I draw squares. For smaller sizes, I draw circles. This isn't the recursive part. We haven't done any recursion yet, nor have we done anything really related to recursion. But now we can. Just like we saw before, our base case is going to be based on the size. So if the size is greater than 0.005, notice I wrote this the opposite of the one that we did before. The recursive problem I did before, I said if the size is less than something, then stop. Here I'm saying the opposite. I'm saying if the size is greater than something, keep going. And there's an implied stop if it's not, right? It's implied that it will stop if it's not greater than that size. All right, we have two recursive calls. To get from this square, this big square, up and to the left, I am subtracting the size from the x-coordinate, and I'm adding the size to the y-coordinate, right? I'm moving to the left and up, so negative x, positive y. And the size itself, I'm guessing, is being cut in half. The size of the square is given as the half length, not the entire length. So I'm guessing that size is being cut in half. That should take care of the upper left. Let's try it out and see, actually, that takes care of the upper left. Okay, it does. Take a look. Square, square, and then eventually it switches to circles once it gets below a certain size, just like I expected it to. So then to do the bottom right, we would need to go positive in the x direction and negative in the y direction, but otherwise it's going to look very similar. And there we go. We can compare that to our reference drawing. I think we got there. Just like the last drawing problem that we did, right? Am I going to take points off if this number's a little off? No. For this problem, I actually think on the exam I told you what this number was. I think I told you that all squares are bigger than this and all circles are less than this. If I don't tell you on the exam, use your best judgment. I won't count off points for that. That is not something that I'm worried about. I'm worried about the switching of the shapes and the two recursive calls that are moving top left and bottom right. That's what I care about for this problem. Are there any questions about this one? Yes? Yeah, so I kind of touched on this a little bit. The last base case, I was more explicit about it. When we did this problem, I said, if the size is less than something, then stop. But here I didn't actually say that, right? I actually said the opposite. I said, if the size is bigger than this, keep going. What's it going to do if the size is less than this? Well, nothing, right? There's nothing. So it'll stop. Yeah. Good question. Or another question that somebody kind of asked me about, right, last class is like, how do I know a method's over if there's no return statement in it? Well, if I hit the end of the method, there's an implied return down here, right? It says, I'm done. It's there. It's definitely there. Any other questions about this problem? Yes?
Why didn't you just do RDraw instead of standard draw?
RDraw is the name of the method. So this is a recursive method call. That's my recursive method call. Recursive draw. Any other questions? Code writing number 2? Okay. I don't see any other hands for this one, so let's do code writing number 2. We wish to draw a dashed line. We're given a value of x, and so we want the dashed line to go from y is 0 to y is 1. So this is going to be a vertical line. going all the way across the screen, right? Starting at the bottom, going at the top. We're going to tell you which coordinate of x we wish to draw this dashed line at. Okay? This is a great example of a problem where I didn't tell you whether to do this recursively or iteratively. You could do it either way. So we could do it both ways if you're interested. But since it doesn't actually say, I'm tempted to do it iteratively. And so I think that's how I'm going to start. I'm going to start doing it with a loop. If you all are interested, I'd also be more than happy to go through this using recursion as well. But let's start with the loop. Let's start with the loop first. We want to start at y is equal to 0 and go to y is equal to 1. And think about the lengths of the dashes and the lengths of the space between should be 0.002. So I can actually write a loop for this. It's a little interesting though, right? Because I want y to go from 0 to 1, and my increments are decimal values. So instead of saying, int y, I think actually y is a double here, right? For double y starts at 0, y is less than or equal to 1. And then how much is y going to go up each time? This is maybe the tricky part. Y is equal to y plus what? It's not 0.02, it's actually 0.04. I think I heard somebody over here say that. It's 0.04 because I'm drawing the dash, which is 0.02, and then I'm leaving a blank space of 0.02 for a total of 0.04. So we're going to add 0.04 to y every time through. And from here, we simply have to draw the dashes. So every trip through this loop, I'm going to draw one dash. Where's that dash going to be drawn from? It's going to be drawn from, well, which method do we need to use? It's going to be the standard draw dot line method. So 2 pairs of coordinates. Where do I want my line to start and where do I want my line to stop? The x value is going to be the same, right? It's a vertical line. So the x values will be the same. So it's really just what we want our y values to do. And actually, this is just going to say plus 0.02. I think that's it. I'm trying to think if I forgot anything or if there's anything else that I need to do. Let me try this one and see if it actually, yeah, beautiful. Beautiful. That looks like a dashed line to me at an x value of 0.25, right? And if I wanted to, I could come down here and I could, do it again. Give me another one at 0.9 as well. I want one at 0.25 and at 0.9. And there we go. Here's 0.25 and here's 0.9. Beautiful. Dashed line for each. So for using iteration, it's really that simple. Do you all want to see me do this recursively or no? I see at least one person. I see. All right, let's do it recursively too. Why not? To be clear though, as written, I would accept this problem just like that. Don't force it to be recursive if it doesn't have to be. You don't need to do that. But let's try it out. Let's see if we can do this recursively. I'll call it dashed recursive. And we'll take in our double x. I misspelled recursive. I'm terrible at spelling. That's why I became a computer scientist. That's not true. Okay. So let's think about it. At every value of x, we need to have some way of keeping track of what our y position is, right? So in other words, in my loop, I had a double called y and started that out at 0. And then from there, I could try to do my base case. I stopped when y was greater than or equal to 1. So, I'd say something like, if y is greater than or equal to 1, return. But otherwise, I need to do some, recursive stuff here. I need to do some drawing. But I think there's already a problem. Does anybody else see a problem with the direction I've started moving in? I set y to be 0 here. That's meant to, just be the starting value for y. And then I check my base case. Well, is y ever going to be greater than 1? No, I set it to be 0 right before. Well, let's think about this in a slightly different way. This line in my loop version, right? This happens how many times? Once at the very beginning, and this happens a whole bunch of times, right? So I need to separate out the stuff that happens once from the stuff that's happening a whole bunch of times. What do I do with recursion if I need to separate out repetitive stuff from non-repetitive stuff? What do I have to use? Helper method. Great. Helper method. That's one of the two reasons that I've explained we use helper methods for. Does anybody know what the other reason is why we like to use helper methods? I'm sorry? So you said keep track of the index, and I agree with you, that's true for a large portion of the problems that we've seen helper methods used for. However, I don't think it's necessarily has to be the index. Any value that I want to keep track of that is not currently accessible to me. I think we actually need to do that here as well. I need my helper method to not just have a value for x, but also have a value for y. If I don't know my current y position, I cannot draw the line, right? I cannot draw the line properly. We need a helper method to isolate the repetitive stuff from the non-repetitive stuff, and also to keep track of our y position. So this is actually not going to go here. We're going to make a helper. Dash helper. It'll take in double x and double y. That allows us to keep this up here and move this repetitive stuff, checking the base case, down here. But I have to connect these two together. How do I get from this method to this method? Or how do I get from any method to another method? I am in this method, I wish to go to that method. How do I get there? What do I have to do? Starts with a C. Method call, we have to call that method. So if I want to get from here down to my helper method, I actually have to call dash helper. And that means I have to plug in x as well as y. I could actually simplify this, right? I think I don't need this at all. I can just say y is equal to 0 to start. All right. If y is greater than 1, then we're done. We've gone off the screen, so I'm going to stop. Otherwise, what do I need to do? I need to draw a line. So I'm going to take this line of code from up here. I'm going to put it right down there. And then I need to say, keep going. I'm missing my recursive call. So I'm going to say dash helper. The x is going to remain the same, but the y value is going to go up by that amount, right? So that I'm in the proper position to draw my next dash. So we'll increase the y amount by 0.004. And I think we're done. But let's test it out. If I come down here and I say dash recursive, I'm now using my recursive method. Let's see if it gets me there. Yep, still does. I can do both of these recursively. Although actually it might be more interesting to kind of compare and contrast these two, right? Because one point I want to make that's very, very important for you to understand. One trip through this loop is doing exactly the same amount of work as one trip through this recursive statement. I think that's very, 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 very important to understand. I want to actually show that to you using the debugger. If I set a breakpoint here on line 35, the first thing that it's going to do is it's going to draw that dash line at x is equal to 0.25 using my recursive method. So watch what happens when I step in and I start drawing some stuff. Here's the first thing that gets drawn. And Where's my window? There it is. You can see, there's the first tiny little dash, right? Drawn at the bottom, and then it says, all right, scooch up 0.004 and keep going. Oh shoot, I hit the wrong button. I'm sorry. I meant to click step into and I clicked the wrong button. I'm sorry about that. Let me start it over again. All right. Draws the first little dash. Takes a second for the first one because it has to spin up the window. Draws the first little dash. This time I will click step into. You can see, all right, now y is at 0.004. So it's going to draw the next little dash. There it is, right? There's the next little dash. That's my second trip through the recursion. If I keep stepping, I'm now at 0.008. So it's going to draw the third little dash. There it is, right? See how it's every trip through the recursive method, I'm drawing one additional dash until I get through the top. Well, let's take a look at the iterative version and see that it's doing exactly the same thing. If I step in here, first time through the loop, I draw that line. There's my first little dash down at the bottom. Next time through the loop, notice where my y value is. It's now at 0.4. So when I draw that line, it draws the second dash. Next time through the loop, I'm now at 0.08. So I'm going to draw the third dash, and so on and so forth. The iterative version and the recursive version are drawing the line in exactly the same way. They're just using two different paths to get there. Cool. Are there any questions about this problem before we move on to another one? Anybody have any questions about this problem? Yeah, question.
I just have a sort of a general question. So, when we're using standard draw functions, we have to know like what each different variable means, or will you provide that information?
Yeah, so if it's from standard draw, honestly it could be from anywhere, but standard draw is one of the more common ones that you would expect to see. I will tell you how to draw circles. I will tell you how to draw squares or whatever you need to draw, right? If you don't need to draw circles, then I'm not going to put that on the exam, but if you do need it, I will give it to you. You do not need to put standard draw methods on your cheat sheet. That's kind of the bigger takeaway. You do not need to memorize them. But if I say, I mean, quite literally, what will you see on the exam? Right? You'll see something that looks very similar to, where's one of the methods that I just used? I used square or circle, right? If you need to draw circles, you'll see something on the exam that looks very similar to this, right? On the exam, just given to you. And from this information, I would expect you to know how to use this method to draw circles in your code.
So you won't actually define like what alternatives are. Like I was thinking about like,
This is given to you, though. I mean, it says double x, double y. It tells you what the parameters are. Yeah, definitely does. Mm-hmm. Any other questions? I'm not going to provide the entire, I mean, that's kind of what I was just saying. I'm providing the entire API would be quite overkill. I will provide the parts that you need to complete the exam. This API is huge. Yeah, I'll give you the ones that you need to do to complete the problems that are on the exam. How it's on the exam doesn't really matter. It'll be there when you need it. Yeah. Any other questions? Anybody have another problem they'd like to see me go through? Do I need to start picking some? Definitely have time to do some more. Yeah. Problem 2, absolutely. Wait, I'm sorry, could you say that again? Didn't I just do the code writing problem 2, the dash line? Is it a different number? You want to do number 3? Okay, yeah, let's do number 3. This is another recursive drawing program that wants us to do this image. Can I zoom in on this so we can see a little better? Okay. Recursive drawing problem. We're starting big and moving smaller, so the two directions I'm moving, well, I kind of gave away part of the answer. I was supposed to ask you how many directions I'm moving in. I'm moving in two directions for this problem, right? I'm going down and to the left and down and to the right. And then it continues moving down to the left and down and to the right. So, okay. With that in mind, we can start to piece this together. We're always going to need to draw the shape. So here's the square, and actually you'll notice that Eclipse auto-fills this in with the parameters, and honestly that's good. That's what we want. Draw this square, and then figure out what squares you need to draw next. That's how these recursive methods work. Although actually, we first need to check if we need to draw any squares, right? Have we hit our base case yet? So, if the half length is greater than some arbitrary value, then I need to go down and to the left. That'll be box C. So moving to the left would be subtraction of the half length rather. Going down is also subtraction, so I would subtract the half length from my y coordinate as well. And the size, or the length rather, is going in half, I think. I mean, we'll find out in a second once we try to run this. Let's go ahead and give this a go. Yeah, there's down and to the left. Looks like we're moving in the right direction. So I just need to figure out how to do down and to the right. That's going to be a positive x direction, but still negative in the y direction, because I'm moving down in both cases, right? So y is negative, so I'm always moving down. X is negative when I go left, x is positive when I go right. So if I just copy that line and flip the sign, run this again, there we go. Yeah, this was a particularly short and sweet one. And I think that's also, I mean, I'm pretty sure I gave you similar advice on the last exam, but that advice still holds true on this exam. None of the code that I'm asking you to write for these problems is going to be pages and pages and pages. It's all going to have the possibility, at least, of being short and direct. So if you find yourself writing pages and pages, I hope that puts, a red flag in your brain of like, there probably is a more direct route to this answer than what I'm taking here. Might be worth your while to find it. Any questions here? We have a different question they'd like for me to see. We have time to do at least one or two more of these coding problems. Yeah.
I have a question about code reading phase.
Okay.
It is a small question.
Code reading number 8.
Yeah.
Okay.
After the if and else statement, there is no curly bracket. So
Yeah.
how does it work as needed?
So you know what happened here? If you would like for me to let you know what happened here, the curly brackets should be here. You may remember hearing me say in previous classes that I absolutely hate writing if statements that don't have curly brackets, although technically it is allowed to not have the curly brackets as long as there's just one line. And the reason why it was done this way on this exam has nothing to do with the code and everything to do with the fact that I was trying to squish this problem onto a page and it wouldn't fit. And so I took the brackets off just to save myself a couple of lines. In hindsight, I kind of don't like that. I kind of wish I would have left the brackets in because I think this is confusing. But that's what happened, just to be entirely clear. It has nothing to do with the problem and everything to do with me trying to squish this problem onto a sheet of paper. But honestly, this code runs exactly the same with the brackets there as it does without. So please put them in if it makes you feel better. Honestly, it makes me feel better to have the brackets in. It runs exactly the same. Hope that answers your question. Did you want to see me go through this one, or I feel like I might as well since we're here. So the method that you're given takes in an array of values, and it takes in an integer location as well as an integer for the count. It looks like that this is actually going to be recursive, right? So this is a recursive method. I see down here that it calls itself. It calls itself. So what's happening here? Here comes an array of strings. So I'm calling this method with the array, and the number's 1, 1. All right. So if the location is 1, the first thing that's going to happen is it's going to print out whatever value is at that location. So that's going to print out the letter T, correct? So that would be the first thing that I would expect to see get printed out. It's going to compute the next location. So 3 times 1 is 3, plus 1 would be 4. So I'm now, next is equal to 4. If our current location is even, which it's not, we'll just go ahead and skip that. If the current location is 1, which it actually is, then I need to, that's actually our base case. So we're going to return the value at position 0. So I'm going to get E. So I believe that actually for this first statement, I'm going to see T followed by E. I believe that's all I'm going to see. It doesn't actually do anything recursive for this first statement. Let me comment this line out real quick and run it and see if that's in fact, yes. I got T and E. So nothing recursive actually happens with this one. It goes right to the base case. I suspect that won't be true for this one. Let's walk through this one real quick and see if we can't figure out what's going to happen. Same array as before. Going to print out the value at the given location. That's the first thing it says to do. So 0, 1, 2, 3, 4. It's going to print out this R. Maybe I'll start writing this down. R is the first letter. What's going to happen? It's going to compute next. So 3 times 4 is 12, plus 1 is 13. This is even, right? 4 is even, so it's going to divide 13 in half, which means we're actually going to be at 6 because it's integer division. So next is equal to 6. We have not hit the base case. So we're going to come down here and we're going to call this recursive method with the same array. Next is now equal to 6, but count has gone down to 3. So this is going to go down by 1 each time. Might even want to write that down for yourself down here. Select with the array. Next is equal to 6, and count is down to 3. All right, what's the next thing that's going to get printed out? I'm going to print out the letter at position 6. Again, this is recursive, so I just went right back up to the top. 0, 1, 2, 3, 4, 5, 6. I'm going to get the A. I now have to compute what the next value is going to be. So 3 times 6 is 18, plus 1 is 19. I'm going to divide that in half as well to get me 8. Am I doing this properly? I feel like I might have taken a wrong turn somewhere. Did I make a wrong turn? Oh, thank you. Next is location divided by 2. So it wouldn't be... it shouldn't be 6, it should be 2, right?
Right, it should be just 2.
Thank you. Yeah, I felt like I made a wrong turn there. Thank you. So we're not going to get the A, we're going to get the I. Sorry about that. Thanks for correcting me. All right. And so this is still true. This is still even. So our next value is going to be 1. So the next method that gets called is going to be select with the array 1 and 2. All right, so I print out the value of position 1, which is T. And then we have to figure out all this stuff again. Actually, I don't even need to worry about this because, or no, I do. This is odd. So the next value is going to be 3 times 1, which is 3 plus, oh, well actually we're kind of right where we were up here, aren't we? The next call is going to be, or we're at the base case. Since this is 1, we're at the base case. So we're just going to return whatever value is at position 0. It's going to return the E, but because this is inside of a print statement, it's going to print it out. So these aren't actually going to get printed. Those were just my notes. This is what's going to get printed. RITE. My little way of letting you know that you got this one right. I know that's not how you spell it. I told you I was bad at spelling. I want to point out though, if it seemed like I was working through this problem a little bit quickly, I was, and I want to explain how I was able to do that and why I was able to do that. I noticed that, you know, if this is true, then this doesn't matter. So why am I going to waste my time computing this if the current location I have is even? I can just skip it. Same thing with the base case. If I see that I hit the base case, then none of this stuff matters, right? If the location is 1 or 0, then I don't need to do any of this arithmetic. I'm just going to do this. So I can skip all of that. Definitely use that to your advantage. I think if you can logically reason about these methods so that you don't have to spend all of your time, you know, computing these things out when they're not even actually going to be used, that's to your advantage. It's to your advantage on these kinds of problems. This was kind of a tricky one though. Little recursive one that uses arrays. Kind of a tricky one. Any questions on this problem? Got time to probably do one left. Does anybody, one more code reading or writing problem if somebody's got one for me? Yeah. Question 4, the code writing. All right. Want to create a method to create and fill an array of doubles. We're going to create an array of doubles with size n, where n is the input parameter. We're then going to iterate through the array and fill it by reading doubles from the scanner parameter. Okay. The method should then return the filled array. Perfect. And then there's another part down there for us to finish after we get through this one. But let's do this one first, and then we'll go down and take a look at that next one. So notice that it's passing scanner as an input. We've used scanner before, so that shouldn't be a problem. But let's start with the array stuff. We need to create an array with size n. So I'll create, actually it needs to be an array of doubles. So double array. And the size needs to be n. That's easy. We then need to go through the array. You could just use n here, since we already have it. If you wanted to use array.length, that's also okay, right? Potato, potato. Either way. For each value for this array, we want to use the scanner to read in a double. This is another example of where, you know, the API call would be provided to you if you need it. But the way that we get stuff out of our scanner is by saying something like in.nextDouble here. Oh, I forgot an equal sign as well, didn't I? There we go. Yes, what's up?
Yeah, should we have a system.out.print statement before the array assignment? Instead of like asking the...
That's a good question. Should we have a system.out.print statement asking? It doesn't say that. It actually doesn't. I mean, we use scanner to read stuff in from the keyboard. We also use it to read stuff in from a file. So we're actually suggesting, by doing it this way, we're suggesting that this method can do it either way, either by reading from input or from a file. Yeah, yeah. I don't think I would count points off if you put a system.out.print line here. I just don't think it's necessary. So the problem definitely didn't explicitly ask for it. Just said to read in the values from the scanner, and that's what we're doing. Then the only thing left for us to do is to return that array once it's finished. But there's another part of this problem. We want to make a program that's going to draw user-defined polygons. So, we're first going to ask the user to specify how many sides the polygon should have. Then we'll use our filled double array method to create those arrays for us. And then once we have our arrays, we'll use the standard draw polygon method to actually draw the polygon. So remember, again, this is information that would be provided to you on the exam. The polygon method takes in two arrays, one for the x coordinates and one for the y coordinates. So we need to use the scanner to read in first how many sides the polygon should have. So we'll do that with next int. We're not using a file here, so it might be wise for us to include a print statement just for our own sanity. Just for our own sanity, even though it's not specifically requested of us. This will tell us the number of sides. We're then going to use our fill double array method. So I'll make an array for my x values, and I will call fill double array, passing in how many sides I want and the scanner. I'll do the same thing for my y's. Again, passing in how many sides I want and the scanner. And then finally, we just need to call polygon that passes in those two arrays. This will do it. This will do it. If you want to test it out, you actually can. You have to type in a bunch of values, though. I'll try and keep it somewhat straightforward by just doing 3 sides. And now it's waiting for me to type in the x values. So I didn't have a prompt here, right? You asked me, should I have a print line? Well, we can see that maybe it would have been nice to have one, because now it's sitting here waiting for me to type something in. I know it's supposed to be an x value. So, all right, first point, I'll do x of 0, then I'll do x of 1, and then I'll do x of 0.5. And now it's waiting for the y values. Again, it would have been nice to have a print statement here to let me know that that's in fact what needs to happen. For the first y value, I'll do 0. For the second y value, I'll also do 0, and then I'll do 1 for the final y value, and then should hopefully draw my polygon, which is a big old triangle. Yeah, that's what I was looking for. I definitely would not count off if you didn't include these print lines in there, but if you're actually testing this, I think it's probably better to have them. So if you're, trying this out for yourself, I would definitely include them, but the problem didn't request them. I didn't take points off if you didn't include them. What I was really looking for here is, can you call this method properly? Fill double array method properly. Notice that it's calling the method and storing that return value into a variable, which is then being used to draw the polygon later on. That's the big part of this problem. Are there any questions about this one? Okay. I'm not so sure that we do have time to do another code writing problem, so I'll probably go ahead and call it a review session, but I will stick around if you have any questions, you want to come up and chat to me after class. Otherwise, we don't have studio this week. You do have an assignment due, though, so if you want to come to class on Wednesday and Thursday and turn that in, the TAs will be there, but there is no studio. So otherwise, enjoy your week. Hope studying goes well for you. Let me know what I can do to help you, and I'll see you at the exam on Thursday.